Alright, so continuing with that handout about the airfare and the distances, on the back side they gave us a lot of information. So here's the scatter plot again, and we can see a residual plot just like the one I constructed a second ago for that other example, the beer, blood, alcohol one. So you definitely need to be able to construct a residual plot. I showed you one way to do it, there's other ways as well. That way is preferable. So I think a couple of your problems will have you construct residual plots. So this one's already got a residual plot for us. And what they ask, number one, is the linear model appropriate for actually using in this instance? In other words, for estimating airfare from distance. And why? Why is it appropriate or not appropriate? So we have two things available to us that we should be able to use to make that decision. Number one, we should be looking at, r squared. So r squared, why don't we put that here? We've got a printout this time. It says 48.2%. That's the number we had a second ago. 48.2% of the variation in the fares can be explained by the variations we're seeing in the distances. Don't think that's too low, because a lot of the time r squared greater than 40% is something that you have to live with in real scenarios. This scatter plot's kind of spread out, but a lot of the contribution to that smaller value of r, I think, has to do with a couple points in here. This scatter plot has a couple points which are not necessarily outliers, but they definitely could be considered outliers, and like this guy and this guy are really contributing a lot to bringing that r rating down. And that's something that we're going to be learning as we approach the chapter called Regression Wisdom. That's something that takes a little bit of experience and time to acquire. So a great way to decide whether that number is high enough is to investigate the residual plot. This residual plot is pretty randomly spread. Yeah, there might be kind of a little bit of this trend, but you can't let a point determine a trend. So something like this and this, they don't determine the trend. If those are removed from the data, it's extremely random. So that's more evidence that our model is appropriate. So how would I answer this question? The book answered it like this. They said, since the scatter plot is straight enough and the residuals clearly show no pattern, the linear model is appropriate for predicting what they want us to predict in this case. So now you have two ways to decide whether the linear model or whatever other model, because we'll be using this same technique for other models, is good enough. Number two says, how strong is the model? I think I kind of already addressed that. That's going to go to the correlation value. So what they said is 48.2% of the variability in blah, blah, blah can be accounted by differences in distances traveled. So they basically used r squared and the interpretation of r squared to answer that question. I think that's a good way to go. Number three says, identify any outliers, and if they are there, why are they unusual? So I already talked about how there's a couple different points in the plot that might be outliers. I think you could really talk about either of those. The book chose to focus on this one. They said this was an outlier, and it is. It's far away from the rest of the spread of the scatter plot, far away from the model, the line as well. In fact, it looks like flying about 700-800 miles, something like that. Let's see, we're counting by 200, 400, 600, 800. That looks like about 700 miles or something like that. Only cost $150 versus most of the 600, 700 mile flights in there cost quite a bit more. About 25% more in the 200, 250 range. That's quite a big difference. So that's decently possibly an outlier. This guy might also possibly be one. We don't have enough data to really say that that's as much of one as this, where we have a lot of data in that area. So that's why we'd say that guy's probably an outlier. Let's see what else they asked. They said, write the equation of the model. I think we had the equation for this one, but how do you read that off a computer printout? Let's go look up in the printout and see if we can pull out the relevant information. So here's how you pull relevant model information out of a printout like this. That's important because this is the kind of output that a lot of statistical software packages, which you'll use in college, like there's a thing called R, there's another thing called Minitab. This is what their outputs look like. So you got to be able to read them. So basically, the stuff's there, you just got to be able to read it. It's different than our calculator. So where are the numbers for slope and intercept? Constant coefficient is talking about the y-intercept. And that's the y-intercept we had a second ago. This says standard error of coefficient, t-ratio, probability. We're going to be learning what some of these mean later. F-ratio is something we'll learn after the AP exam. It's much more advanced. So you're going to ignore a lot of this information, at least until later in the class. That's the y-intercept. So where do you think the slope is in this plot? Just use process elimination. Distance is the x variable, so it's the coefficient attached to distance. That's what a slope is. It's the coefficient attached to your x variable. So there's your slope. So you could use those two things to write down your model. We already did that in the last problem, so I'm just going to say that's it. Predict the airfare for a 1,000-mile flight. You know, plug 1,000 in. That's an x value, right? Make sure it's not a y value. Plug it in. Make your prediction. Let's move on. So now they give us some more computer output. Let's see, what do they do here? They said write the equation of the model to estimate how far you could fly for a given price. This is kind of flipping the scenario on its end and seeing if that's any different. Let's use the computer output and write that down. So write the equation of the model for how far you could fly. So this time y is distance, so I'm going to say distance at equals, and I'm going to use those two numbers. So my slope is 6.131. My x value is fare, or you could put dollars here or something. And then my y-intercept is going to be negative 644.287. Don't let this computer printout scare you. A lot of it's just distracting information at this point at least. Then it says, how far does this model suggest you could fly for the fare you estimated in 5? I guess we'd have to go back up and estimate that and plug it into wherever it goes here. You can see that the residuals are still randomly scattered. That makes sense because it's basically just the same model. It's just an inverted version of that model. So I think that's all you need. I'll see you in class next week.